let's cover the examples that we have here on the screen. So those are what we are gonna get to. So now let's find the actual process in which, or the order we have to follow in order to get there. If you're given 5 pi over 6, in reality, what you are being asked to do is to find the quadrant, the reference angle, the sines, and the terminal point. Let's go ahead and do that. So let me begin. So 5 pi over 6, we should start by sketching a circle that will be divided into 12 pieces. The denominator tells you the number of pieces you need on each half. This is quite a terrible circle, but it's just to get an idea. So this is 1, 2, 3, 4, 5. So 5 pi over 6 looks like it should be at quadrant number 2. So we're talking about quadrant number 2. The reference angle, since we have 5 pi over 6, 5 pi over 6, you can either try to go for 0 pi over 6, 6 pi over 6, or 12 pi over 6. The closest base is 6 pi over 6, so that means that you are pi over 6, an angle of pi over 6 away from it. Now, if you talk about quadrant number 2, so we're talking about this angle being in quadrant number 2. This is a quadrant where the x is negative and the y is positive. We're gonna be expecting negative and positive. Now, the terminal point is based on the reference angle. So if the reference angle is pi over 6, we're gonna be using that specific angle. So if you think about pi over 6, it's kind of having a reference angle of pi over 6 over here and producing the same coordinate, square root of 3 over 2, comma 1/2. But since we are in quadrant number 2, the signs have to be updated accordingly. So at the end, you're going to be talking about minus the square root of 3 over 2, comma, positive 1/2. So positive 1/2. Now, for the next one, we're going to have 7 pi over 4. So that means that we need 4 pieces on the upper half and 4 pieces on the bottom. So that's 1, 2, 3, 4, 5, 6, 7. So 7 pi over 4 is in quadrant number 4. Quadrant number 4. The reference angle, if you're thinking about 7 pi over 4, so you have, once again, 3 options: 0 pi over 4, 4 pi over 4, or 8 pi over 4. So once you have those, the closest base is 8 pi over 4, and you are pi over 4 away. This is positive and negative. Since we're in quadrant number 4, x is positive, y is negative, and the angle that we're using is pi over 4. So we're going to be sketching that particular triangle here. And the coordinate produced is going to be, once again, square root of 2 over 2, just like up there, comma, square root of 2 over 2, but with the signs according to the quadrant. The minus the square root of 2 over 2 and the square root of 2 over 2. So that's the idea behind angles that are trapped in between quadrants. Now, this is just the terminal point. Using a terminal point, you can find any trigonometric ratio. So at this point, if I ask you to get the, let's say, the sine of 5 pi over 6, you would be able to tell me that since sine is equal to y, and we know what y is when the angle is 5 pi over 6, it would be equal to 1/2. If you now are perhaps asked to find cosine of 7 pi over 4, that would also be possible since I know that the terminal point has an x value of 7 pi over 4. The terminal point is minus square root of 2 over 2. So the solution would be minus square root of 2 over 2.